Hello everyone, the topic for today's video is half adder and full adder. As the name suggests, these both circuits are used to add binary data. So this is basically the integrated circuit of half adder. It has two inputs and two outputs. The outputs are sum and a carry. What this circuit does is, it adds the inputs A and B, with which we would obtain a sum and also a carry. Because we have two inputs, the number of states would be 4, and that is 0 0, 0 1, 1 0, and 1 1. So the value of A plus B would be, in this case, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0, 1 plus 0 is also 1, and 1 plus 1 is 2. The binary equivalent of 2 is 1 0. So this 1 is the carry bit. So if I write this inputs and outputs in a more organized way, in the form of a truth table, it would look like this. So here A is 0 and B is 0, where 0 plus 0 is 0. So the sum is 0 and also the carry is 0. And 0 plus 1 is 1, so the sum is 1 and carry is 0. 1 plus 0 is also 1, hence sum is 1 and carry is 0. When both the inputs are 1, then the output is 2, whose binary equivalent is 1 0. So the sum is 0 and the carry is 1. Now let's obtain a digital circuit for half adder. To obtain the digital circuit of the half adder, first we need to obtain the expressions for sum and carry. And we can find out the functions of sum and carry using the k-maps. To plot k-maps, we need to find out at what states of the inputs A and B the sum is high. So we see here, when the A is 0 and B is 1, the sum is high. When A is 0 over here and B is 1, which is here, we need to mark it as 1. And when A is 1 and B is 0, the sum is again 1, which would be at this position. Now to obtain the expression of carry, we see when both the A and B are high, the carry is high. That means when A is 1 and B is 1, the carry is 1. Using this, we can obtain the expression of sum and carry. For sum, it can be written as A dash and B plus, at this position, B is low and A is high. That is A and B dash, which is also A XOR B. And for carry, at this position, both the inputs are high, which is A and B. So using these expressions, we can obtain a digital circuit for the half adder. Now I'm going to show you the simulation of the half adder. So we obtained the functions of carry and sum. To design a logic circuit, we need XOR gate and AND gate. So here's an AND gate and an XOR gate. Both take the same inputs A and B. So I'm gonna take two switches and connect the same for both the gates. Now I'm connecting the outputs of the gates to the light bulbs. After totally organizing the circuit, it would look like this. So here we have the inputs A, B, and the output sum and carry. So we can check the truth table with this circuit. If A is low and B is low, both the sum and carry would be low. If A is high, then only the sum would be high, as there is no carry. And also if only B is high, even then there would be no carry. But if both the inputs are high, we have the sum of 2, for which the value of sum is 0 and the carry value is 1. Well, Thank you for watching. If you like this video, subscribe to my channel.